Hey everyone, welcome back to our channel. In today's video, we are diving into one of the most underrated topics in the designing. Every mechanical engineer faces this question when starting a design. Should I build each part separately and then assemble it? Or should I sketch the whole layout first and let the part adapt to it? Also, some of the engineers didn't even know the difference. They just start using the bottom up approach. The reason is, in most of the videos on any learning platform are focused on the bottom up approach, and nobody tells you the difference and when to use them. But in this video, we will be focusing on both the approach used in designing process and how these can help you to enhance your workflow and improve the accuracy. Basically, these two methods are called bottom up approach and top down approach. Now, let's start with bottom up approach. The bottom up approach is like building with Lego, means you design the individual part first, each as the separate file, and then bring them together into assembly. The assembly is built like a puzzle. Independent parts are combined using the mate and constraints. Imagine designing a gearbox. First, you create the gear as one part, and then shaft as the another part, and then bearing. Each component is modeled independently without worrying about the others. Once the parts are ready, you bring them into the assembly and apply the mate and the constraints and secure everything inside the housing. The advantage here is modularity, means designing something in a self-contained, reusable building blocks that can work independently but also fit together in the different assemblies. If you have already designed the set of gear for one project, you can reuse them in another. Supplier parts like bearings and fasteners can be dropped directly into your design. But there is a drawback. If the shaft diameter changes, you must manually adjust the gear bore and the bearing hole. The parts didn't update automatically. That's where the top-down shines. Now, we will see how it works. The first process is part creation. Each part is modeled independently as .prt or .sldprt file, that is SolidWorks part file. After creating each part, then it comes to assembly stage. You open the new assembly file, insert the part into the assembly, and apply the mate to position and constrain them. And then the final assembly is ready. Once everything is positioned, you check the motion, interference, tolerance, and clearances. And this is good, but only in specific cases. Now, if we talk about the advantage while using the bottom-up approach, the first one is modularity, as we discussed. The standard parts like bearings, screws, motor can be reused across multiple designs, saving your time, effort, and ensure the consistency in designing. Then we have parallel work. If you are working on the large project that require multiple people to work on the project, different team member can design the parts separately and later bring them together. Perfect for large product handled by multiple team members. Also, we can use the library. You can directly import the supplier parts from the catalogs. This reduces the error in dimensions. Also, the bottom-up approach provides flexibility in early stages. Great when you are not sure about the final layout, but you know what parts you will use in designing. Despite of having all these advantages, there are few drawbacks of using it that you must be aware to ensure the smooth designing process. Like there is no chance of automatic updates. Suppose if you change a part, let's say you change the shaft diameter, then the related part, that is gear bore and the bearing, won't update automatically. You must fix them manually. Also, it's time consuming in complex designs. For highly integrated assemblies like car interiors or smartphone, the manual adjustment take too long. Then there is less control over relationship. Since the parts are designed independently, ensuring perfect fit alignment require extra checking. Now, moving on, we have top-down approach. The top-down approach means you start with overall design layout or the skeleton inside an assembly, and then create the part in context, referencing this master geometry. Instead of designing part independently, you let the assembly drive the part. Imagine we are designing the same gearbox while using the top-down approach. Then you will start with the master sketch in the assembly. You will draw the shaft center lines and their spacings, define the relative position of gear. Then from this layout, you create each part in context. The shafts are extruded directly from the center lines. Here is a power. If you later change the shaft spacing in the master sketch, the gear and the housing updates instantly. This makes the top-down ideal for the project where the fit and alignment are critical, like automotive gearboxes or aerospace assemblies. With such a easy approach, it has lots of advantages, like design intent is captured. The master sketch ensures all components follow the design rules, and it's perfect for high integrated designs. Then we have automatic updates. Changing one parameter in the skeleton sketch, all the link parts are adjusted instantly. This saves huge time in designing process. It provides precise fit and alignment. Since all the parts are built from the same reference, they always align perfectly. And it's great for packaging designs. Work well in projects where the space and fit are critical. Now, there are few things that should be kept in mind while using the top-down approach, like complex dependencies. If in any case the reference break, for example, the skeleton sketch is deleted or altered, many parts may fail. Also, it has less modularity. Reusing the part in another assembly is harder because it's tied to the specific skeleton sketch. Then we have difficulty in collaborations. Multiple designers working on the same assembly can create conflict if not managed properly. In bottom-up approach, we start with independent parts and bring them together. It's modular, flexible, and great for projects that rely heavily on the standard or supplier components like gearbox, pump, or tooling fixtures. On the other hand, the top-down approach starts with the bigger picture, a master layout or the skeleton that drives every part. This makes it perfect for tight integrated system where the fit and alignment are the critical, like engines, aircraft structures, or consumer products. And remember, many industries today actually use the hybrid approach, that is combining the best of both, reusing the standard component while relying on the master layout for the critical relationship. And at the end of the day, the right approach depends on your project goals, team structure, and design intent. So you need to be specific about what is your design intent and what process will be best for designing. If you found this video helpful, don't forget to hit the like button, subscribe for more CAD mechanical insights, and share your thoughts and comment which approach do you prefer in project, that is top down or bottom up. See you soon with another exciting video.